we go back to what Viessmann gives you as a standard, right? So you got standards from, gas codes and plumbing codes, things like that. And every manufacturer is going to have a standard as well, right? Their installation, their service manuals. In here would be all the information that we talk about on water side. What do we want to see the boiler as far as the quality of that water? And you can't see that by just pouring the water in a bucket and seeing that it's clear. There's a lot of stuff in there that we were concerned about. That information is in the manual here. Any service documentation Viessmann has will give you that information. The VI 2035 that Nahani talked about before Brody took to the stage. But in this manual service instructions is all the information about how to clean these boilers properly. It's a standard, right? This is what we expect you to see. With standards, however, everybody has different levels. And some guys have a much higher standard. I talk to guys that basically, when they talk about service in the boilers, they make sure that the heat exchanger looks like the day it was installed. Viessmann standards are not quite to that level. But I don't want to pull those guys down. If that's your level of standard, then maintain it. That's excellent. But what we're going to talk about today is what Viessmann, the procedures that Viessmann will give you in this manual to basically follow. Important to note that when we take these doors off, we lift them up. So we're going to lift the cabinet up and then pull it towards us versus just grabbing the top of the boiler and kind of heaving that thing towards you. The reason why I say that, you've got these little plastic clips and they slide the door into place, and I've seen these little hinges break, these little clips will break as a result of just kind of reefing on the top of the boiler. So lift it up and pull that door towards you is kind of what we would recommend. Also, I like to point out that we've got on the documentation, a lot of times you might not see the manual I showed you, but you'll have this document. And this is a wiring schematic. It's a factory wiring for the boiler, the internal, as well as the external stuff. So I'm pulling plugs off of the boiler here when I'm doing the service. And all those plugs have a number on them typically. And this little reference here will tell you, once you, like I got this spare plug, what do I do with this plug? It's got a number on it. You can always refer back to this little document here, the schematic, and find out where that missing plug is supposed to go into. So it's, some guys like to take pictures, that's fine, but there is always this little document that's usually kept inside the boiler. It never disappears from there, and that's a really good area for it, and it's always kind of sitting there. So I just wanted to point that out before we get started. Power button, powered off, display goes down, that's blank. There's still power in the control, so if we're pulling this control out and doing troubleshooting, you have to be aware that even though there's no screen here, there's still live power in the back of this control. We're not going to do that today. We're strictly about service, not so much about the troubleshooting. In behind here, this is where you do a lot of your field wiring. Your boiler pump, for instance, on the bottom here, this little fella, that's pumping water through the boiler whenever it's firing up. It is wired directly to this little junction box on the bottom of the boiler. And we're going to shut the gas off. So in the very back here, there's a gas isolation valve. We've shut that off already. Basically, so if we pull this burner out, we don't have to worry about gas basically escaping out of the boiler enclosure there at all. So safety first is something that we always kind of keep in mind. So just make sure that we don't have any of those things that are in an unsafe condition. Once we get to try to pull the burner out, that's the first step in your service. These little barn doors, right, on the control here, where your power button is, we want to close that. On this side, you've got your pressure gauge on the bottom. We always want to see that kind of around the green area of the pressure. Your reset button for lockouts. If you have a combustion control lockout, there's your reset button. And of course, you've got your what we call OptiLink in the Viessmann term. Those are just lights basically. So when I turn the boiler on, we get a green light, and that just tells you there's power to the control. If you have a red light here, and it's flashing or solid red, that's telling you probably have a fault on the boiler, something that the boiler wants to bring your attention to. So it's off, you're not gonna have anything there. We're gonna make sure those doors are closed. We make sure that these little clips are in the full down position. Otherwise, you're gonna have a little fight to get this control off. And in my experience, there's guys that are strong enough that they can force this control down. If I have my Wheaties in the morning there, I might be able to strong enough to do that. And these little red clips will pop out and they'll go flying. So the idea there is to make sure they're in the complete reset position. There's a little bit of information here on the control, just a visual thing that you can see to tell you to push that all the way down. When we're doing service, it's important to keep this little cover on the control. right? If I pull this cover off, there's live voltage back here. And of course, if I'm doing service, I'm going to be adding water or washing this heat exchanger, and if water gets on this control and it gets exposed to that line voltage, you let the smoke out of the control, as they say, and you can't put the smoke back in, right? That's going to be a new control. So some guys will go to the extreme of, depending on what they're using for water, for washing, they'll cover this with plastic or something like that, and we'll control the water here today fairly well, so to avoid that type of a problem. But control of water is important when you're doing service in these low mass boilers, because you're going to have that spray back and stuff like that. So just be thinking about how I'm going to clean that boiler and make sure you have the appropriate tools to do it. In that little document that I sent out, and Nahani and Michael and Murray printed off and added to the folders for you guys, the first or second page gives you all the kind of recommended tools to service these boilers. So once I get to this point, I've got these little 8mm nuts. You're going to back these off. I loosened them up here already, but we would tighten these back. And they're just basically holding this enclosure in. When I put that door back on, it seals this whole area. That means that if I've got a 2-pipe system, so I'm pulling combustion air into the boiler, with that door on, it's completely sealing, so we're not stealing air from the room. We're taking all our air from the outside. So it just depends on how you have that combustion air piped as to how important this little angle bracket is as far as its operational function. So I'm going to pull this basically towards me. The newer your boilers, the less your service. It's a little bit stiff there, but you're just going to give it a little push towards you, and you can take that little bracket off and basically just set that aside. Next, once we have that basically removed, now we can attack the burner here and pull this out. There's a couple of different ways you can do this. My recommended method from the manual would be to basically this little block on the downstream of your gas valve here. There are a couple of 4mm bolts. I've taken a couple of them out, and in the manual they'll recommend to pull the burner out this way. I've also taken the nut off here on the gas valve. Important when you're doing this, make sure the gas is isolated, so that when you open this up, if that's open, you're going to get a lot of gas moving through this little 1-inch corrugated stainless steel pipe. But you can crack the nut here, and basically there's another 4mm bolt right in here that you would have to back off to remove that whole gas valve. And sometimes I like to do that if I'm kind of looking in. I want to see a bunch of different components in the back of the boiler to show you. Today I'm going to do it as per the manual, and we're going to stick to this little side of the gas valve. We're going to pull this out. It's 2 steps. So basically we've got these little bolts here. I'm going to try to not get in the way of the camera while I'm doing this. And the longer the burner's running without service, the longer that service procedure is going to take. So we're going to have a look at that. So we've got that little block out. On the other side of the block, it might be hard to see in here, but there is you'll see it when I pull that out. There's a little gas pressure switch in there. And the gas pressure switch I have to remove the coil from. You'll see there is GDW2. I'm going to butcher some German here. That's Gas Drucker Wasser 2, gas pressure switch. And basically, there's another gas pressure switch on the backside of this gas valve, which is GDW1. That's a low gas pressure switch. So anything below 4 inches, the burner won't fire, but you're not going to get a fault on the boiler. It basically sits there to wait for that gas to basically come up above 4 inches, and then it allows the burner to operate if there's a call for heat. These are big boilers, so more important to make sure that gas pressure is accurate before the burner fires. So we have a low gas pressure switch there. You might also have a manual low gas pressure switch on your gas line here, depending on where you're at. I know a lot of areas where I'm from in BC that we have a manual switch on that side. The safety authority likes to have something that it manually locks out if there's low gas, so they'll have that. This is not, this is an automatic reset switch. So now that I've got that basically unplugged, so I can now freely remove the gas train here out of the boiler, the portion that I need for service. I need to also remove my ionization electrode, and that's sitting right here, and as well as the ignition electrodes. And the ignition electrodes, there really doesn't matter which way you put these back in. So if you forget, well, this is the lower one, the upper one, there's no polarity on these. It's just basically based on the length of the cable. So typically the shorter one goes in the top, longer one goes in the bottom there, but it's just about the stress of the cable depending on where they're sitting. So you can have a look at that. That's it for that side of it. We've got a couple of plugs here on the burner fan. So modulation of your boiler is always about fan speed, and that's what this little plug is here, the 100A. It basically is the signal from your control. When the burner wants to ramp up modulation, it's going to pulse a signal, and you're going to get a faster pulse of electricity to your fan, and that, or cycle I should say, and that's going to basically increase the fan speed. So it's a modulating fan based on load. So the higher the fan speed, the more gas is being pulled in and sucked into your venturi here. We're going to have a look at that in conversation about venturi in a second. And of course, the higher the modulation, the lower the fan speed, and that's the pulse rate of this 100A plug, the lower the burner firing rate is going to be. And on the back side, there is another plug. It's the 100 plug. We'll see that in a second when I pull the burner out. And that's basically the power to the fan, 120 volt AC to this particular fan. All right, so before I unplug everything here, I'm going to remove the electrodes. I find them easier to remove when I have the burner still in play here, just to inspect them. This is the ionization electrode, and ionization basically is responsible for basically flame proofing. It's a safety in the boiler to make sure that when that boiler fires, that there is a feedback in microamp DC. So if you're trying to measure that, it's difficult on these boilers because they have a combustion manager. But basically, you're going to get a feedback on this. And of course, the more reliable the flame signal, and this is what the electrode looks like, the better, basically the better the burner is going to operate, the more reliable it is. As these get fouled up over time, then of course you're going to have a problem because now that flame signal is going to be a little bit weaker. And when they drop down below a certain level, that's when the boiler says there's no more. We're going to block that burner from operating. We can't prove that there's a good flame. We don't want to destroy the components inside the boiler and make it unsafe, so we're going to lock that boiler out and down. This is the ionization electrode for this boiler. You might notice this one here is a little bit of a different look to it. This is a newer style ionization electrode that Vitodens recommends for these particular boilers. Larger sizes, just from tech and troubleshooting and stuff like that, we found we get a little bit more longevity out of these particular electrodes as far as flame safety. And what they're called is a knife electrode or nickel ferrous. So this is the ferrous part of the electrode here. It's standard, it's the same as the one we just pulled out, but it has an extra little piece of nickel welded on here, a little closer to the burner mesh. And when you're dealing with things like low gas pressures and stuff like that, which we can't control as the manufacturer, but they're within spec of the boiler, this will pick up weaker flame signals a little bit better, a bit more conductivity, and we have a little less issues as far as EE and EB faults. So this would be the new style electrode that you'll end up getting. So if you have the older one and you want to basically replace it, you might end up with this particular one. All right, so we'll just torque these bolts in. And I'm not going to tighten them down until I have both of them in because you don't want to cross thread these. I'm going to soak this down a little bit when we fire this fella up to make sure that there's nothing leaking out of here, right? Just to ensure that that gasket was indeed, still had its integrity. Important to do that stuff. Anytime we open up anything here, we want to make sure that when we close it back up, we're not having an issue. So you see this electrode here, the gasket fell out. I can't reuse this gasket, it's broken, so I need to replace that. So I'm going to have to basically scrape that stuff off there to make sure that I've got all that removed. We'll slide the new electrode in. I've got the fresh screws with it here, and we'll just slide this back in. Now there's only one way these will go in. If I try to put them in the other way, they're not going to go in. We want that angled back towards the burner. Otherwise, you're going to have ignition faults because the spark is going to be away from the burner there. So There we go. So those are out, and I'm going to show you how to measure that gap and distance when we take the burner out. That's a Torx bit, and it's important to have the right tools for the job when you're doing this. All right, so we'll pull this out. It's a bit of a tall boiler room as far as where the boilers are hung. It's for maintenance of the system that they put the boilers up at this height, but you would want to get up a ladder. Something that's possible. You didn't quite have height here. We're going to have to get up a ladder to do the combustion test, but I should be able to pull this out fairly easily. We've got everything basically out here. So this is the burner that we're dealing with. Just get a good look inside. So basically, in the Viessmann world, we use a real technical term, coffee grinds. That's kind of what it kind of reminds us of. And this is not unique to Viessmann, right? Anything that burns hydrocarbons, as I mentioned from the beginning, has got this somewhere in that heat exchanger. Whether you can see it or not, it's still there. What I like about this particular style of heat exchanger, it needs maintenance, and Viessmann by no means is basically saying you never need to maintain your boilers. You need to maintain these. We recommend on an annual basis preventative maintenance, just like your car, right? You drive that car, how many hours you do a year, you got to change the oil after so many kilometers. These boilers have over 15,000 hours of operation time on them. So you think about your car. If you drive that car for 15,000 hours, how many oil changes have you had in that vehicle? How many times have you had it in and had other different types of maintenance done? So same idea here. We're driving these boilers. They are basically a hydrocarbon-based type of fuel, and we need to make sure we get that stuff out. So think that's the same kind of thing as changing the oil in your vehicle. Same kind of idea. So we're going to break this. We're going to pull this stuff out. So we're going to use a vacuum cleaner here. It's going to get a little noisy as I vacuum the stuff out. So the first thing is to get the loose debris out. Doesn't take long. If I was to basically be satisfied with this, pat myself on the back and put this boiler back together, I really haven't done the most important thing. That's getting into these flue gas passageways. And we've got a special little knife that we can use for this application. And the whole idea is that if I look at that tide mark, you can see, if I can get in there, you can see where that debris was sitting. You can see the dark, basically still the staining on the heat exchanger. Most of that's going to come off after we do the service here. But it's a really good guide as to where we need to basically address. See how that knife is not getting into those areas? I got to make sure I'm not going to take this knife and basically stab at the heat exchanger. In the manual, and the information comes with this little cleaning tool, it says we don't want to gouge the heat exchanger. It's not made to scrape the heat exchanger. What I'm trying to do here is there's dimples that basically keep the gap consistent between the coils. So as this burner heats up and expands and contracts, those gaps are always at about a 0.8 millimeter distance between each other because of the dimples. But I can't take this little knife and basically move it, more than the space that it basically can fit into. Those dimples are going to be on either side of it. So it's not for scraping, it's to actually get in there and punch down through these coils to make sure that that flue gas passageway is open. So my whole goal here is to go front to back, all the ways back here, all those gaps, to make sure that I have that heat exchanger good and clean. That means that now all those flue gas passageways are open, 360 degrees around, nice even heat transfer. Every area of that coil is going to get a similar basic temperature from the flame. So we're not basically having little hot spots built up in the boiler. And I would usually get up with probably a little bit on a ladder here. I'm going to try to do it without that. Use my ape arms here to get a little bit farther back. I don't have to worry about these bolts here or this washer falling into the heat exchanger. In comparison to the bigger boilers that we have at Viessmann, the coil here is small enough that the gap that these aren't going to fall in. So I was pretty secure in the fact that I didn't have to get in there and catch those bolts where they fell. But not all boilers are like that. You want to make sure in some of the bigger ones, bigger commercial boiler we're going to be working with later on today, that we don't have anything on the side of the boiler that's going to fall inside there. We might lose that in the heat exchanger. And now that I pulled that out, I can take my little tool here, extend it out a bit, and I can grab that refractory and basically pull it ahead a little bit so that I can capture it. There we go. And then we make sure we put this in a very safe place so it doesn't fall. This is a little pressure washer kind of thing you would use to basically spray your plants and stuff. You had some, but it's a great little controlled flow of the chemical. Anytime I use chemical though, I'm going to make sure that I'm going to get in here afterwards and I'm going to make sure I flush all this chemical out of the boiler. I do not want to have this chemical inside this boiler. Doesn't matter what kind of chemical it is. Unless it's water, you want to make sure you flush that out when you're doing your washing. But see how that's bubbling up there and you got that on the surface? That's going to clean that up really well. I'm going to really just soak this in. And it's going to do most of the work for me, right? I don't have to basically do a lot of heavy labor here. We're not going to get to clean this whole surface of this one here. We did yesterday on the boiler to the right, but we're going to let this fella here kind of soak. If this was extreme, what I would do is I'd actually remove this P-trap inside. I would pop that off and I would plug that area off, whether you just taped it or put something, cork in there, whatever, and secured it. The condensate pipe off of that. So take the P-trap out, the little stainless steel pipe that this is connected to, secure it and basically isolate it so basically water can't get out of it. And I would flood this heat exchanger. And when you flood it, basically what I'm talking about here is making sure that you get enough water in there or chemical mixture in there. It almost starts to come out the front of the boiler. And you're saturating the tube now in the area that it's going to have the most density as far as debris, kind of plugging up the heat exchanger. And you might have to do that a few times to really unplug the debris that's kind of stuck on the heat exchanger. What happens is year after year, that stuff gets more and more compact in there and it almost becomes like a cement. And I've seen in a lot of areas where I'm from that we go to boilers and they're plugged up severely, that we got to do a fairly decent chemical flooding like that, and it takes a few applications. But like I say, what I like about citric acid is that it's not a solvent-based cleaner. So as far as using it and kind of draining it out, it's not that it's got some acidity to it. In comparison to using some of the more aggressive stainless steel cleaners, you don't want to flush that stuff down your drains. You kind of want to capture it and dispose of it properly. So we got that pretty covered up there, and we'll just leave it. It's the venturi of the boiler. We call this where the fuel and the air are actually meeting. This is the first spot that your combustion air is coming into the boiler, and of course your gas is coming through these little slots, just kind of the inside of that venturi. And this is where the air and the gas are entraining, they're blending. We call it a premix burner because everything is pre-mixing, fuel and air, before we actually get it to light off on the burner tube here. So if this is really fouled up, and I kind of put my hand in there and finger and I kind of pull a lot of debris out of there, then I know that there's a lot of contamination of combustion air coming in. That's going through the burner and it's coming out on the catch-all here. This little mesh is the burner mesh. And of course, if this is dirty down here, this is going to be fouled up as well on the burner. So I'd have to pull it out and we'd have to use a vacuum or whatever and vacuum both the inside and the outside of that little burner tube. If this is clean, I don't worry so much about this side of it. So on annual maintenance, if I notice that this is nice and clean in here, that tells me that this is not basically going to be dirty either. It's basically downstream of the venturi, so I don't have to worry about it. But there is one area that we'll look at here. So I'm going to show you that. And I'm also going to show you there's a flapper that sits in that combustion air area as well we want to inspect before we put the burner back together. And I'll explain what that little flapper does in a second. So I already took the bolts out just to kind of speed it up a little bit. But basically this little refractory is sealed down onto our burner flange with these little clips, one per little slot here. And we have these little 4mm bolts. You'll see me put them back in and they secure down on there. I put these little screws in an area that they're not going to fall down because you need to make sure that you don't have 3 of the 4 bolts and say, well, that ain't bad. You need to make sure you have all the bolts. I'm going to get in the way here. Good headshot for you. There, I got all those screws out. And now I can remove the burner mesh. And there's 2 pieces to this. This is the only boiler of this size, basically. You've got your burner tube, and on the other side of the burner tube is a turbulator. So basically what this does is it balances out. As we have that fuel and that air blending through here, it creates basically a pattern for that to go down the tube here. So we have a nice even distribution of that gas. So we have a nice even flame around the cylinder of the burner here. So we're just doing a little inspection here. You can see a little bit of dust and debris on that. That's not going to be of any issue as far as operation, but we really want to hone in on the mesh here. It looks like it's in pretty good shape. You can kind of see where the ionization electrode sits, also where the spark electrode sits in there. You can vacuum it off, and we're not really scrubbing with a vacuum cleaner. It's just a light, basically, kind of brush of that, and just getting any debris off of that. I'm going to do that after I'll do a little bit now, but after I put the refractor back on, sometimes you catch a bit of the refractory on this mesh. So I'll have to vacuum it again. And again, there's the refractor or the gas we're talking about. And we would be looking for things like breakage or something like that in the gasket. That could be a problem. If we see a break, then we would basically want to replace the gasket. If we didn't have a replacement, we'd want to get one on order. We're looking for this little flange area to be nice and flat. This only goes in one way. Right, I don't want to do that. See how basically the turbulator is actually still standing up. There's a slot that it needs to sit into. See how that's now nice and flat in there? If this is not installed correctly, you're really got to be careful that seat's in there. Otherwise, you put this down and you put the bolts in. You think you got that sealed, but now you've got an opening there, so it's not going to close off properly for us. So we'll slide that back in. It's like deja vu. There we go. That's all the French I know. Just like I did it before. If you have a screwdriver with a magnet on it, because you got to put that in a little bit deeper, and of course this makes putting these bolts in a little bit faster for you. That's why I like the Vitodens tool here. I don't go to a job site without this. It just makes my life a little easier. An area I want to point out with the burner flange is the burner gasket. There's a gasket that we can see here around the burner. And we're just checking that basically to make sure that that burner gasket's actually still there. Sometimes if the guy hasn't torqued the bolts down correctly, this little burner gasket will basically start to disintegrate, dry out, or crack. We want to make sure it's nice and pliable, right? Make sure that it's going to basically seal up correctly. If that thing fails, it can basically create an issue with your heat exchanger. And if I was to grab the information in the service manual, and these were not new electrodes, and I want to check their gaps and stuff, make sure that they were good to go. I believe in the manual it's going to say something along the lines of on the ignition electrode, 6 millimeters, 5 millimeters, and 4 millimeters. If you've got Allen keys, so let me see. I got some Allen keys sitting here. So when we're measuring the gaps, what I'm talking about here is the distance of the electrodes from the burner mesh. And 6 millimeters, I would have a 6 millimeter Allen key. And if I slid that basically between the burner mesh and that electrode right there, I'm going to angle this for you a little bit so you can see a little better maybe. That's going to slide in there, and there's a tolerance. So this one here is a little bit bigger, but just get the idea. That gives me my gap. And then I would be looking for 5 millimeters between basically the Let's turn this right around for you here so you can see it better. Right in between the bottom electrode and the side of that other electrode. And then 4 millimeters between the top and the bottom. This is where the spark actually is, between the top and the bottom, so we measure that off. And then 14 millimeter Allen keys slid between here. We would just make sure that reference that little gap there. So very quick with it, if you have the right Allen keys to do that with. Basically make short work of that. And there are tolerances there that you can look at as well to make sure that that's going to be good to go. And the last thing, as far as service goes on these, and inside of here is a little flapper. And the whole idea behind that little flapper is that it basically protects the boiler against negative pressure in your buildings. So if you had kind of think about if you had your boiler room and the burner fired, and then you turned on an exhaust fan, or that building, that area was under a constant negative pressure, and that burner stopped firing. If that flapper wasn't in there, your vents, your exhaust vent actually becomes a ventilation duct. And if it becomes a ventilation duct, the flue gas pulls through the vent, down through the burner again, through your burner tube, comes basically down the chamber here and comes out the venturi. And it damages components as it goes, that damp air. And that's going to cause your burner basically and your boiler to start breaking down. You're going to start getting some faults related to that. You'll start having more frequent service requirements for your boilers. You'll also have issues with parts. You have to have basically more repair parts for your burners and stuff like that. So it's important that we basically have a look at this. It's a 4 millimeter Allen key in there that we got to get. I'm just going to crack this guy. There we go. And we'll have a look at this little flapper. The purpose of it, why it's actually in there, is these boilers are also approved for common venting. So if I wanted to basically have instead of having multiple vents out the boiler for whatever reason, I can basically only have one single vent. I can put up to 4 of these boilers on one vent system, and this little flapper protects this boiler when there is no, there's no burner firing in this boiler, but the other boilers are firing from that flue gas backing into that this particular boiler's heat exchanger. So what I'm talking about here is basically I've got the fan separated now, and there is my little flapper sitting in here. I don't need to pull it out. It gets sticky in there sometimes. I don't want to break that. So what I'm checking for is how flexible, usable that is. Make sure it's there. This one's in really good shape. You know, moves back and forth. I should get that so you can see it. I can see it perfectly. But I'm looking at that little flapper in there, so you can see how that operates and it's doing its thing. So when we have a downward force in that flapper, it's like a check valve. It closes off and air can't flow. If I have basically an upward force, it pushes that little membrane out, and then away we go. Another area to check while we have it open is right here on your burner flanges. This is really nice and shiny. These boilers are 6, 7, 8 years old, I think. And if I saw this like dirty, like pitted in here, like a dark gray and pitting, that tells me that we got flue gas recirculation. So we're pulling in flue gas into the venturi, and it'll stay in the aluminum. This one here is really nice, like the day it was installed basically. So I don't worry about flue gas recirculation with this particular boiler. So I got all that stuff checked. Everything looks good. I could put the burner back together here now. So let me perk this up a little bit. We are really adamant in the manuals about using metal brushes and stuff like that to avoid using those in these stainless steel heat exchangers because they can cause corrosion. You don't want to gouge the heat exchanger with this knife either, but it is, the idea there is to get these gaps open. So the goal is to have that basically so that it cleans that full passageway. And you can see as we work this, it's really kind of, as it's been soaked in chemical there for a little bit, it's gotten pretty soft, and I can work that down pretty effectively. So you can see how dirty that is inside of there. If I didn't get that with the knife, you're not going to wash that out very easily. You need to have the assistance of that force here to get that stuff basically cleaned out. So I'll do a couple of sections here as we move through. Get that one a little bit more. There we go. Some are going to be a little bit more dirty than others, depending on where the buildup was. Now what I can do, you know, as if I've cleaned this, we did this one here already yesterday, it went right from front to back. So I'd want to do that front to back. And also, if I'm dealing with different issues like F1 faults, vent faults, maybe you have combustion air contamination. I know this blower doesn't have that issue based on the burner, but I'd want to get into these gaps on the top as well, just to make sure that we have no issues. These are nice and clean. But if you have kind of service faults, vent sensor faults in particular, where you have high vent temperatures, you need to go around that whole heat exchanger and make sure all these gaps on the top are nice and open as well, right? To make sure that you don't have any problems. As you can see, this is going through pretty easily on this little heat exchanger here. Just remember that there's some areas I can't go through. There's a dimple there, so I have to move it over a bit and basically move this little knife through there. I would also, at this point, remove the P-trap and put a hose or something and take it down to a drain. So what we're going to do here is kind of do a little bit backwards. Once I get that debris kicked out of there, it's sitting at the bottom of the heat exchanger here now. I need to get that flushed out. Otherwise, when I start the boiler up, it's going to actually go down with the condensate and it may plug up my P-trap. And then of course you're going to have that condensate back up in the heat exchanger and end up with some sort of a problem or fault. So we're going to wash this out. Again, we got electronics here. You want to have really good control of the water flow as we clean this boiler. So some guys will use, instead of a nozzle like this, they might use a piece of 3/8 copper tubing, 1/2 inch copper tubing. They'll flatten the end of it so they get a nice little distribution nozzle on it and a little needle valve or something like that, so they can really control their flow. We'll work with what we have here. We used it yesterday quite effectively. Now, we usually, if we clean the gaps, so see how the water's kind of moving ahead a bit? I know some of these gaps are still kind of plugged. That should flush out fairly quickly. I want to get all of that chemical washed off the surface. Being careful of where that water's going. Checking down on the P-trap here. That is just full of all the debris that we cleaned up. So see if I can get, yeah, it's a pretty silty mess in there, but if I grab some of that so you can see, that's the stuff that's plugging your boiler out. You don't get that out, that's going to cause issues with your boiler long term. So that is that's our goal there, is to pull all that stuff out. Put this back. A little bit, dry it off. Cap here. Basically, what this little guy serves, the purpose it serves is it's sealing up the enclosure, so when you're pulling air from outside, you don't have that hole where the P-trap sits basically causing an issue for you. So it needs to go in first, and actually needs to basically be kind of pushed through. And then we can get our P-trap back into place here. Gasket, it's okay. Put it back up in a second. Alright, so basically once we get this little bolt torqued down here, the washer does the tightening there. It will move, that's natural, it's just protecting that back wall. I'm going to hit this with a little bit of vacuum, but the important thing is these gaps in here, get that flue gas passageways opened up. And if you do that, then you're successful as far as you're getting your boiler up and running. So let's get that burner on. I can basically get this burner on here. The height creates a bit of a challenge, but we will persevere. I don't want to start with a screwdriver tapping those in. They should go in really smoothly. That burner gasket I talked about is doing all the work. So I want to make sure that I'm not going to cross thread these bolts. we want to do the soap test. So we've got some soap tests here. And basically all of the areas that I've removed, I had a little area around the gasket here. I want to spray that. The bolts here in this area here, spray it with some soap. And when the burner goes to fire, that fan pressure is going to make sure that if we see bubbles there, we need to tighten that stuff up, make sure there's going to be no issues with that. So a leak detector is always something you need to have in your toolkit whenever you're doing any type of service. Once you get all that stuff established, what we can do now is fire these boilers. I've got that back in there. I'm going to give that just a back it off a turn. I don't want to pull it all the way out. And then I have my gas pressure gauge. I use a magnehelic gauge. I like these because they give me a good idea of gas fluctuation, pressure drops, those types of things. I'm going to put that on my gas valve and I turn the gas on. There we go. And in the manual it's going to say you don't start the boiler if you're below 4 inches on your pressure or above 14. So we're pretty good to go here. We can fire this boiler. That's what we call static pressure. So if I'm in the manual, I've got my maintenance manual there. In the documentation, you're going to have an area that you can mark the date you're doing your service, and you can also basically start recording this information. And it's important to record this stuff because year over year, if you start seeing changes here, it might be why you're having problems with the boiler. So it's important to kind of document that. So there's your static pressure. And now we can turn the boiler on. And I'm going to make a test here. I've got the gauge still on. We'll pop it up here. You can see that we're 11 inches of pressure here. And if I want to control the burner, I want to turn this into, put it into high fire. I can get myself into service. And I just don't want the burner to fire here. I want to control it. So if I go into service and I see diagnosis, that's a great area for service information, temperatures and set points, etc. Actuator test is where I'm going into. And I'm now controlling everything. I can turn pumps on manually. I can basically control mixing valves. I have mixing valves on the boiler. But when I turn the boiler on and it fires, base load is low fire. And full load, if I put in the full load, the boiler's eventually going to go to high fire. So when I'm doing a running gas pressure, we call this running pressure, dynamic pressure. What we're trying to achieve here is the boiler gas pressure on high fire dropping down below that 4-inch critical mark for natural gas. If it was propane, we can't drop below 10 inches of gas pressure on high fire. So your tolerance are even tighter if you're on a propane system. So it would be between 14 and 10 inches, natural gas between 4 and 14 inches here. This boiler is doing a calibration right now. So basically, I can tell by the fan speed, it's doing a burner calibration, so it's checking the flame signal, doing some referencing here. And you can see how stable that gas pressure is. That's what you want to see. I don't want to see that basically doing a lot of fluctuation there. If that's fluctuating during this particular process, it usually will end up in some sort of an ignition fault. The burner wants a nice stable function here. So I think we just passed the calibration. What they have here, they only have one gas reg on these boilers. You would really want to fire all your boilers on high fire because you want to see with all those boilers on full load, where does that gas pressure end up? It's nice when they're individual regs because now you basically test these boilers. So there we go, high fire, that's stable at high fire, and we're no higher than about, we dropped to about 8 inches. So last check is what we do is lockup pressure. So with lockup pressure on commercial boilers, it's like when we shear a flame, where does that gas pressure go? Does it bump up as a result of that flame shear above 14 inches? This one's stable right back up to 11 inches. So we've got static at 11 inches, high fire about 8 inches, and then lockup was about 11 inches. So everything's safe to go on this boiler. We can basically now turn the boiler back on. What I did there was I went into coding level 2 by, we already were in the service level, OK menu, OK in the back key gets me to coding level 2. I went to general first, and the idea there was to look at address 8A. 8A is an address that kind of opens up other addresses if it's at 176. Usually it's at 175, I got to change it to 176. This one had already been at 176. Obviously somebody's already been in this control, kind of doing the same thing. Once I get 8A 176, I hit the boiler, scroll down to boiler, push OK, hit the left arrow key once. This number, 48, tells me the quality of the ionization on ignition. Anything above 10 is what we're looking for. So at 51, we're at a really nice number here for this boiler. And as this drops, this is an area that you can check. And if you're doing some maintenance, whatever, and you come to this address 48, you see it down below 10, you can take the ionization electrode out, give it a little scout, pop it back in here again. And then when the boiler fires again, if you go back to address 48, you'll have a reference here, it'll probably be a little higher than 10 at that particular point in time. It tells you if your ionization electrodes are starting to wear out. 46 tells me that I've got 34 more burner cycles on off before it calibrates again for combustion. And 44 tells me flame kind of recognition, or essentially how quickly that gas valve opened, and we had flame formation, so about 2 seconds, which is really a good number. So this boiler it looks like it's in good working order. I just wanted to kind of reference, these are not in the manual, I put them in the supplement that you guys have with you, in case you want to review that. It tells you how to get into all this particular area of the boiler. So this is basically it. We kind of looked at how to service, and then we looked at basically after the service, checking gas pressures, make sure all the stuff is stable, and what that combustion analyzer does, what the value of that analyzer is going to be. Because now we know this boiler is in good operation from low to high fire, and all the points in between will be good to go.